So let's look at an example and see how the performance of RISC is compared to the performance of CISC architecture. Let's assume that we want to write a series of codes or instructions that multiplies two numbers from the RAM. Let's assume that our RAM is basically just a table of values which has columns and rows. In this case, for example, we have 3 rows and 3 columns. For example, each of these values has a row and column value. In this case, row 1, column 2 has a value of 2. If we use CISC instruction sets, we can simply use a single instruction, which is in this case happen to be mult, and multiply row 1 column 1 by row 2 column 1, and then the result will go back into row 1 column 1. So in this case, what we're doing is we're multiplying 1 in row 1 column 1 by 4, which is row 2 column 1, and then the result will go back into row 1 column 1. Now if you want to do the same exact thing using RISC instruction set, we will need to do multiple steps. We have to first load the value in row 1 column 1 into a operating register called A. We have to do the same thing in order to operating register called B and load the value of row 2 column 1 into B. Then we have to multiply A and B registers together. Then we have to store the value from A into row 1 column 1. Notice that in this case we have a lot more instructions. As a result, we need to utilize more RAM, and there's also a lot of processing that's going on. Yet we're using very simple low-level instruction, and that's why we really refer to RISC as a reduced instruction set. However, in the case of RISC, a major advantage is that each instruction or code, it takes only 1 clock cycle to execute. So, in general, the CPU processing power inside a microprocessor unit or microcontroller unit can be measured in terms of instructions per time. In other words, we can represent the performance of the microprocessor unit in terms of millions of instructions per second, otherwise referred to as MIPS. When running a particular program, we basically just see how many instructions have been executed per second. Another way to look at this is to measure performance in terms of time per program. It's kind of like reverse of what we just said. So in this case, we have a simple equation. Time per program is equal to time per cycle times cycles per instruction times instructions per program. Now fundamentally, RISC architecture focuses on minimizing the number of cycles per instruction. On the other hand, in CISC architecture, we try to minimize the number of instructions in the program, and that is the key difference between the RISC and CISC architecture. Now, let's see if we can do the next example.